Welcome to Right Tuition Classes. We are doing challenging questions of circle. Challenging questions of circle. This is a lecture one. Okay, in this some three questions I'll do in every lecture. We'll do three questions. Okay. Now, anyhow, children, let's see this question. Question number one: show that the endpoints of the diameter of respective circles drawn through one of the 2 points in which the circles intersect are collinear with the second point of intersection of the circles. You have to understand this question. Show that the endpoints of the diameters of the respective circles, मतलब एक से ज्यादा सर्कल है, respective circles मतलब दो सर्कल तो रहेगा. Show that the endpoints of the diameters, वो circles का diameters रहेगा, उनका endpoints. Okay, show that the endpoints of the diameters of the respective circles drawn through one of the 2 points in which the circles intersect. Oh, this is a big sentence. The two circles, they intersect each other at two distinct points. And from one of the points of intersection, two diameters are drawn. Where the other point of intersection of the diameter, other endpoints of the diameter, you have to show it is collinear with the second point of intersection. I hope everybody has got the question. I repeat, children, there are two circles. Okay, one circle and the other circle. Children, again, these two circles are intersecting with each other. The two circles are intersecting with each other. The two circles you can see here are intersecting with each other. And now you can see these are the points of intersection, okay? You can see here these are the points of intersection, A and B. Got it? Now, diameter, show that the endpoints of the diameters of the respective circles drawn through one of the 2 points in which the circles intersect. So diameters are drawn through one of the points through which the circles intersect. Can you see these are the points? Diameters are drawn. Am I right, children? Like you can see here, children, the circles intersect each other at points A and B. Suppose AP is the diameter of the circle. Okay. And AQ is the diameter of the circle. Now, these diameters are drawn through one of the 2 points in which the circles intersect. Like the circles intersect each other at points A and B. Through A, both these diameters are drawn. Now, which are the other endpoints of the diameters P and Q? You have to show they are collinear with the second point of intersection of the circles. You have to show these 3 points are collinear. These 3 points are collinear. These 3 points, okay? I'll just show it to you, children. You can just have a look at it. You have to show these 3 points. Which 3 points, children? Like P, and Q are collinear. You have to show P, B, and Q are collinear. P, B, and Q are collinear. You have to show this point are the endpoints of the diameter because these diameters are drawn to one of the common points. The other endpoints of the diameter, you have to show it is collinear with the second point of intersection. You have to prove P, B, and Q are diameters. Are you getting me, children? So here you can see here, children, such a question when it comes, okay, we call it as a rider. We have drawn the diagram. We have understood the question and we have drawn the diagram. So when we draw the diagram, it becomes necessary for us to write given. So here, what is given information, children? Two circles intersect each other at points A and B. Two circles intersect each other at points A and B. Now, one of the points of intersection, like A, segment from that diameters are drawn. So how I write? Segment AP and segment AQ are the diameters of the circles. And what do you want to prove that, children? Prove that the second point of intersection, the other endpoints are collinear with the second point of intersection. Prove that points P, B, and Q are collinear. P, B, and Q are collinear. I hope everybody understood this, some children. You have to prove these 3 points P, B and Q are collinear. Collinear मतलब आपको prove करना है तीनों एक ही line में. You have to prove all the three are in the same line. You have to prove these points P, B and Q are in a same line. You can see you have to prove this P, B and Q are in a same line. This dotted line, listen, try to understand this. This dotted line what I drawn, okay? You have to show these 3 points are collinear. I shown by dotted line. Okay, how to show this? Now remember one thing, children. Let's try to understand the concept of showing the points collinear. Let's try to understand what do you mean by what is the definition of a linear pair. Linear pair, please have a look here. Linear pair. When two adjacent angles have their non-common sides as opposite rays. Opposite rays in geometry means opposite rays in geometry makes a line. Keep it in mind, children. Opposite rays in geometry always makes a line. Like suppose this is O, A and OB are opposite rays, okay? They are opposite rays and opposite rays. The moment I call it as an opposite rays, you should understand the union of opposite rays is a line. It is a straight line, okay? Now remember one thing. What do you mean by linear pair? What do you mean by linear pair? When two angles, please have a look here. When two adjacent angles, you can see these are adjacent angles. These are a pair of adjacent angles, pair of adjacent angles. See the condition. They are pair of adjacent angles. And the one side is common. Can you see here, children? This angle MOB is common. Angle MOA. Look at angle MOB and look at angle MOA. This ray OM is a common side. Can you see the one condition, common side? And the non-common side. OB and OA are non-common sides. They are forming opposite rays. They are forming opposite rays. They are forming a line. We say such a pair of angles as linear pairs. I say they are angles in a linear pair. These are angles in a linear pair. Now, what is the converse of it? Please try to understand this, children. Suppose there are two angles, okay? I'm not telling you what is this pair of angles called, okay? Here I say, again, understand my question very clearly, okay? Here I say line AB is a straight line from point O on it, ray OM starts. So this pair of angles, what are they called? They are called linear pair. They are called linear pair because I said line AB is a straight line. Now in here, I'm not saying this OP and OQ, this line PQ is a straight line. I'm not saying. But I'm asking you, what is this pair of angles called? MOP and MOQ. Again, सबका आंसर लीनियर पैर रहेगा. गलत बात है. इधर मैंने क्या बोला? लाइन स्ट्रेट लाइन है. उसके ऊपर एक पॉइंट ओ है लाइन के ऊपर और एक रे ओ एम ड्रॉ किया है. तो ये पैर ऑफ एंगल्स को क्या बोलते हैं? लीनियर पैर. इधर मैंने कुछ बोला नहीं है, पीक्यू स्ट्रेट लाइन है, लेकिन एक फिगर मैं पूछ रहा हूं. गॉट इट? ऐसा फिगर है. ये एंगल्स को क्या बोलूंगा? एमओपी एंड एमओक्यू. आपने लीनियर पैर बोला तो आप गलत हो. आप क्या बोलेंगे इसको? एडजेसेंट एंगल्स. क्यों? क्योंकि आप ज्योमेट्री में अपने आंख का ऊपर बिलीव नहीं करेंगे. जब तक गिवन नहीं रहेगा कुछ बिलीव नहीं करना है. तो एमओपी एंड एमओक्यू, ये पीक्यू स्ट्रेट लाइन दिया नहीं है, तो एमओपी एंड एमओक्यू क्या होता है? एडजेसेंट एंगल्स होता है. एडजेसेंट एंगल्स. अभी ध्यान से सुनो. If adjacent angles are supplementary, 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 okay, then they form a linear pair. Then they form a linear pair. If adjacent angles are supplementary, then they form a linear pair. याद रखो एक converse. If adjacent angles are supplementary, then they form a linear pair. Okay. Now try to understand this. Okay. Now I'm coming to one simple, very simple questions. Okay. Just have a look here. Nothing has been said. Nothing has been said. And I'm just asking you one. This diagram is given. This diagram is given. This figure is given. Angle MOP and MOQ और कुछ नहीं दिया है. So what is this pair of angles called? MOP and MOQ. Adjacent angles. Got it? इसको क्या बोलते हैं? Adjacent angles. तो अब ये linear pair कभी होएगा? Adjacent angles are supplementary, then they form a linear pair. तो मैं एक क्वेश्चन पूछता हूँ. चलो 110 डिग्री है, ये 70 डिग्री है, और क्वेश्चन पूछता हूँ. प्रूव दिस एंगल्स फॉर्म अ लीनियर पैर. तो कैसे करेंगे आप? प्रूव दैट एंगल एमओपी एंड एमओक्यू फॉर्म अ लीनियर पैर, तो आप कैसे दिखाएंगे? एंगल एमओपी इक्वल 110 डिग्री, एंगल एमओक्यू इक्वल 70 डिग्री, गिवन गिवन। सो एंगल एमओपी प्लस एमओक्यू इक्वल 110 प्लस 70 कितना हो गया? एंगल एमओपी प्लस एंगल एमओक्यू इक्वल 180 डिग्री। Therefore ये एडजेसेंट एंगल्स है ना, एडजेसेंट एंगल्स आर सप्लीमेंट्री। Therefore angle MOP and MOQ form a linear pair. अभी समझ गए linear pair? Therefore ray OP and OQ are opposite rays. अगर opposite rays है, that means PQ POQ is a straight line. PO and Q are collinear. Are you getting me, children? So please try to understand this example. Okay, MOP and MOQ क्या है? Adjacent angles हैं. Okay, मैंने बोला prove that it is a linear pair. तो कैसा आएगा? Angle MOP equal 110, angle MOQ equal 70. दोनों को ऐड करो. MOP plus MOQ ऐड करने से कितना होता है? 110 plus 80, 110 plus 70 कितना हो गया? 180. तब adjacent angles क्या हो गया? Supplementary है. तब MOP and MOQ form a linear pair. ओके, अभी मैं बोलता हूं नेक्स्ट क्वेश्चन, यही क्वेश्चन वापस। प्रूव दैट रे ओपी एंड ओक्यू आर ऑपोजिट रेज। ये फिगर में प्रूव दैट रे ओपी एंड ओक्यू आर ऑपोजिट रेज। सो देखो, एंगल एमओपी इक्वल 110, एंगल एमओक्यू इक्वल 70। सो एमओपी प्लस एमओक्यू इक्वल 110 प्लस 70 कितना हो गया? 180. Therefore adjacent angles are supplementary. Therefore MOP and MOQ form a linear pair. Therefore ray OP and OQ are opposite rays. Non-common sides of linear pairs are opposite rays. Okay, तो प्रूव किया हमने। अभी एक क्वेश्चन, थर्ड क्वेश्चन, चलो। प्रूव दैट पॉइंट्स P, O and Q are collinear। तो कैसे करेंगे? एंगल एमओपी इक्वल 110, एंगल एमओक्यू इक्वल 70। चलो एडिंग देम कितना आएगा? एमओपी प्लस एमओक्यू इक्वल 110 प्लस 70 कितना होगा? 180। तो एडजेसेंट एंगल्स आर सप्लीमेंट्री। So MOP and MOQ form a linear pair. Therefore, ray OP and ray OQ are opposite rays. Non-common sides of linear pairs are opposite rays. अगर opposite rays है, that means points P, O and Q are collinear. क्योंकि opposite rays क्या बनता है? Line बनता है। Got it? So I just give you an idea about proving points collinear. So here, in the same way, I want to prove 3 points collinear. Which are the 3 points I want to prove collinear? P, B and Q. I want to prove P, B and Q are collinear. P, B and Q are collinear. Such a simple question, children. लेकिन याद रखो, जब भी आप इंटरसेक्टिंग सर्कल्स देखेंगे, नॉर्मली 100%, 95% ऑफ द सम्स में कंपल्सरी कंस्ट्रक्शन हो जाएगा। Draw segment AB. Construction. Draw segment AB. What is this? Construction. What is this construction, children? Draw segment AB. Construction is what, children? Draw segment AB. Normally, कोई भी सम जिधर सर्कल्स इंटरसेक्ट करते हैं, ये कंपल्सरी कंस्ट्रक्शन हो जाएगा। गॉट इट? नाउ लेट्स ट्राई टू अंडरस्टैंड दिस। ओके, प्लीज हियर, गिवन इंफॉर्मेशन इज ऑलवेज अ हिंट। इसमें क्या गिवन है? अरे एपी डायमीटर दिया है, एपी डाय, मुझे पी बी एन क्यू कोलिनियर प्रूव करना है। अच्छा, एपी डायमीटर है, प्रूफ। ओके, आपको गिवन क्या है? ये सेगमेंट एपी डायमीटर। अगर सेगमेंट एपी डायमीटर है तो इस सर्कल चैप्टर में मैंने बताया सिग्निफिकेंस, एपी इज डायमीटर। तो आपको क्या समझता है? अरे दोनों सेमी सर्कल्स है, डायमीटर एपी का ऊपर, डायमीटर एपी के नीचे, दोनों सेमी सर्कल्स है। और हमने सीखा है एंगल इन अ सेमी सर्कल इज 90 डिग्री। सो सेगमेंट एपी इज अ डायमीटर गिवन है। Therefore, angle ABP equal 90 degree. I call this as one angle in a semicircle. E is a right angle in a semicircle is a right angle. Okay. अरे ABP मिल गया 90 डिग्री। ओके, अभी AB क्यों मांगता है? तो क्या, what is segment AQ, children? AQ is हमेशा given information is a hint. अरे AQ diameter है, segment AQ is a diameter, segment AQ is a diameter. So from this diameter, what we get, what idea I get? Yeah, I get my idea. What is that, children? Therefore, angle ABQ equals 90 degrees. What is the reason, children? Again, I'll say angles in a semicircle. Angles in a semicircle. Angle in a semicircle. Angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Angle in a semicircle is a Right angle. Yeah, I wrote angles. No, angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Shade number 2. अरे दोनों का मेजर मिल गया, अभी दोनों का ऐड एडजेसेंट एंगल्स है. ABP and ABQ are right now adjacent angles. Hey, when I add them, what I get? Angle ABP plus angle ABQ. When I add them, how much you get? Arey, both are 90. 90 plus 90 कितना होता है? 180. Reason adding 1 and 2. Adding 1 and 2. Adding 1 and 2. Now listen here, children. Look at these angles carefully. Don't you agree? Both were adjacent angles. And when I add these adjacent angles, how much I got? 180. So adjacent angles are supplementary. So just now I told you, if the adjacent angles are supplementary, then they form a linear pair. Therefore, I'll just say angle ABP and angle ABQ form a linear pair by converse of linear pair axiom, by converse of linear pair axiom. What is converse of linear pair axiom? If adjacent angles are supplementary, they form a linear pair. If adjacent angles are supplementary, they form a linear pair. It's called converse of linear pair axiom. It's called converse of linear pair axiom. Are you getting me here? Now listen, ABP and ABQ form a linear pair. Therefore, ray BP and ray BQ are opposite rays, opposite rays. Remember, non-common sides of linear pairs always opposite rays. Therefore, opposite rays always determine a line, children. मतलब रे बीपी और बीक्यू एक लाइन में है, समझते आता है. Opposite rays मतलब एक line. Therefore, points P, B and Q are collinear. You can say points P, B and Q are collinear. I hope, children, it was a simple sum. If you would have understood what instruction I gave you in the beginning, then try to understand this sum. It would have looked very simple, children, really simple, okay? I go to the next sum, children. The next sum is, we go to the next sum, children. Yeah, come, it's question number 2, children. In the figure, P is a center of circle. In the figure, P is a center of circle. And what you want to prove is, children, you want to prove the measure of this angle, children, XPZ. Please look at this angle, XPZ, XPZ, XPZ. This big angle, okay, I have to show the measure of this angle. So sorry, it is not seen, okay? This angle XBZ, this red angle XPZ, I have to show it is double of angle XZY. It is equal to angle XZY plus angle YXZ. A very simple question, children. You have to show this big angle, okay? So right now, just have a look at it, children. Very easy. Very easy means very easy. Got it? Just see here how to think about such proofs, okay? They are very simple. The question, the answer itself is giving you everything. Like you want angle XPZ. Don't you agree? Look at angle XPZ. I wanted a sum of two angles. Angle XPZ. I want to show it is sum of twice the sum of these two angles. Well, basically twice of angle XZY plus twice of angle YXZ. So I want to show it as sum of two angles. So don't you agree? You can clearly see your your XPZ is sum of this angle XPY plus angle ZPY plus angle ZPY. You can clearly see this, children. The reason, statement number 1, reason, I'll just say angle addition property. It's not difficult, children, but I see little challenging to the minds of yours, okay? Now, angle XPZ, I showed it as sum of two angles, but I don't want this. I want twice angle XZY plus twice angle. I got it. You see here? Now look at this XPY. Can you see this angle XPY? It is intercepting. Please have a look. It's actually basically a central angle. Angle XPY is a central angle. And it is intercepting, you can see here, children, it is intercepting one arc. You can clearly see. It is intercepting one arc. You can clearly see This angle XPY is intercepting this arc. Which arc, children? R XY. R XY. Angle XPY is intercepting arc XY. Central angle is intercepting this arc XY. But the same arc XY is also intercepted, if you look at it clearly, is also intercepted by angle YZ. Please have a look at it. Angle YZX, angle YZX, or you can call it as angle, okay, angle XZY, angle XZY, whatever you call it. Okay, angle XZY. I repeat, this angle XPY is intercepting arc XY. This angle XZY is also intercepting arc XY. Central angle is intercepting this arc. This inscribed angle is also intercepting this arc. So this central angle is twice this angle XZY. Got it? This angle XPZ, this angle XPZ is twice this angle XPZ, angle XPZ. Can you see this XPZ, children? XPY, children. This XPY is twice angle XZY. This is also called as inscribed angle theorem. If you try to recollect a theorem, children, the angle subtended by an arc at the center circle is twice the angle subtended by the same arc at any point on the circle. Got it? The angle subtended by an arc at the center circle is twice the angle subtended by the same arc at any point on the remaining part of the arc of the circle. So naturally, angle XPY is twice angle XZY. Can I say, we also call it as by inscribed angle theorem. This book, your book is calling this as inscribed angle theorem. So you also call it as inscribed angle theorem. Your book is calling it as inscribed angle theorem, okay? तो XPY का जगह में हम लोग तो हमेशा ट्वाइस एंगल XZY लिख तो सकते हैं, लेकिन ये ZPY का जगह में क्या? Look at angle ZPY. Look at angle ZPY. Now look at angle ZPY. Children, look at angle ZPY. This angle ZPY. Can you see this angle ZPY? I call it a blue color, green color. Okay, it is intercepted by this arc, green arc YZ. But this green arc YZ is also intercepted by the angle ZYX, or you can say YXZ. So you can see here, please have a look here. The central angle YPZ is intercepted by this arc YZ. YZ is intercepting this angle YPZ at the center. YZ is intercepting arc. YZ is intercepted by an angle YXZ on the circumference. So naturally, children, you can see here, children, what I can say is, again, because of the theorem, children, because of the theorem, what you learn, angle, this ZPY, this angle ZPY is twice angle YXZ. Can I say, children, this angle ZPY, what I put it in a rectangular box, is twice angle YXZ, 3, okay? Can I say by inscribed angle theorem? By inscribed angle, you write it as inscribed angle theorem. I'm just putting it into mark. So can I replace this as an angle XPZ equal in place of XPY? I put twice angle XZY plus in place of ZPY, I put twice angle XZY, and I say from 1, 2, and 3, from 1, 2, and 3. Now you can see, children, therefore angle XPZ equal to common, children, angle XZY plus angle XZY. Angle XZY plus angle, what you did a mistake here, plus angle twice angle YXZ. YXZ. So here also twice angle YXZ. So naturally, children, two common, so it will be YXZ, okay? And I think this is the answer we wanted, okay? A very simple sum, but to get this idea, children, people have to really concentrate in the picture. Then perhaps you may get this sum. Okay, that's why I put it as one of the challenging questions. Very simple. Such questions can be asked in your board exam. Okay, now we go to the next sum, children. Very simple question, children. Got it. Actually, they should not ask you here. Anyhow, this question: two circles with centers O and P. Can you see here? Two circles with centers O and P intersect each other in points R and S. M is a midpoint of OP. 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 They are giving. And this line AB is perpendicular to MR. At this line AB is drawn in such a way that it's perpendicular to MR. It's perpendicular to MR. When you join this MR will be perpendicular to AB. Okay. And AB intersects the two circles at A and B. Intersects one of the circles in A, other circle in B. Now, what you want to prove is, children, this AR and BR are congruent. You have to prove AR and BR are congruent, children. A very simple one, children. Why simple? I'll make you understand, children. See, I realize one thing. Actually, AR is a chord of this circle and BR is a chord of this circle. अगर chord का एक very important theorem आपने सुना था 9th standard में, in a perpendicular drawn from the center circle to the chord bisects the chord. इसके लिए we do this construction, draw OQ, segment OQ and segment PS perpendicular to line AB, okay? I draw segment OQ and segment PS perpendicular to line AB. Now, why did I draw this? I told you AR is a chord of this circle, BR is a chord of this circle. Perpendicular drawn from the center circle to the chord bisects the chord. तो अभी देखो बेटा, ये जो QR है ना, QR एक्चुअली QR क्या हो गया? हाफ AR हो गया. QR is half of AR. और ये SR क्या हो गया बेटा? Half of RB, perpendicular drawn from the center circle to the chord bisects the chord. You understand? That's why I draw this. And now you can clearly see, children, so simple now this proof has become. You'll see. Just have a look here. What is the construction? OQ perpendicular line AB. What is MR? Perpendicular line AB. What is PS? Perpendicular line AB. All are perpendicular to the same line. So they are parallel. Therefore, segment OQ parallel, segment MR parallel, segment PS. If there are three parallel lines, then look on transversal OP, OM congruent PM. OM congruent PM, M is the midpoint of AP given it. Therefore, on transversal AB, can I say QR congruent RS? Theorem of three parallel lines. If three parallel lines make congruent intercept on one transversal, they make congruent intercepts on any other transversal. Now look at QR. QR is half AR. What is SR? SR is half RB, but half AR equal. Please have a look here. But QR and BR are equal, so half AR equal half BR. Half gets cancelled, AR equal BR. So AR congruent BR. So once again, I'll just say, children, so simple this is. Segment OQ. Just have a look at the segment OQ. Segment OQ perpendicular line AB by construction. Okay, by construction. By construction, okay? And then, children, look at the other line. Okay, your segment MR. When you look at it, segment MR is also, please have a look at, MR is also perpendicular to line AB, given A. Line AB is drawn in such a way that it's perpendicular to MR at R. And also segment PS is perpendicular to line AB is by construction. So now listen, all the three are perpendicular to the same line. Therefore, segment OQ parallel segment MR parallel segment PS. Since they are perpendicular to same line, now all the three are parallel on transversal. OP, what you see, children? Segment OM, congruent segment OM, congruent segment MP. M is midpoint of AB. But if three parallel lines, please midpoint of AB. But you have learned, children, in your ninth standard. If three parallel lines make congruent intercepts on one transversal, then they make congruent intercepts on any other transversal. Therefore, on transversal AB, on transversal AB, can I say, children, segment QR, congruent segment RS. That is called theorem of three parallel. By theorem of three parallel lines. By theorem of three parallel lines. By theorem of three parallel lines. Okay. Now you can see as I put QR equal RS. I call this as statement number 1. Okay. Now look at this QR. What is QR equal? QR equal half of AR, children. Okay, and what is RS equal? RS equal half of BR, children. These are your statement number 2 and 3, and the reason for both of them is same. Perpendicular drawn from central circle to the chord bisects the chord. Bisects the chord. Perpendicular drawn from central circle to the chord bisects the chord. But don't agree, children, in your statement number 1, QR and RS are equal. This left hand side of 2 and 3 are equal. QR and RS. Therefore, half AR is equal to half BR from 1, 2, and 3. From 1, 2, and 3. Therefore, half of gets cancelled. AR equal BR. Therefore, AR comment BR. Therefore, segment AR comment segment BR. I hope everybody's understood this simple sum, children. Not a difficult sum at all. Okay, children? Anyhow, we go to the next sum.